celebration of Black History Month, we have a special guest. His name is Mr. Darryl Riley. Mr. Riley is the Senior Vice President of Quality Food Safety and R&D for Hostess Brands and serves on the executive leadership team. And now, Joy.
He leads the R&D and regulatory teams for innovation, renovation, productivity, and quality improvement.
And he directs strategic planning, risk management for food safety, quality, and consumer affairs.
Well, Sean, Joy, and Nicholas, I want to say hello to all of you. And I'm so pleased to be here with you to sit and talk to you about our products, to talk to you about the career that I have, and to learn so much more about you in terms of what you do in Kids for Chemistry, which is a fabulous way to learn science and a fun way to learn it. And so I'm really excited to learn about what you want to do in your future, and hopefully I can help support you with what you want to do going forward.
Mr. Riley, what does, as Senior Vice President, do? I'm curious.
So the Senior Vice President is a position that basically looks at what are areas that can help the company grow, that can help make sure the company stays and keeps up a high reputation, but does it with technical people. So people within my team are in R&D, and many of them have either chemistry degrees or food science degrees or engineering degrees. And then in the quality and food safety team, and some of them have microbiology degrees, as well as other chemistry and other biological degrees. They worked really hard to make sure that the food that's made is great, tastes good, looks good, and gets delivered to your door, as well as making sure that the food is safe. And so we work together in order to ensure that the products are both tasty, safe, and that they always, arrive at your doorsteps in that manner.
Mr. Riley, you have a lot of products. What are some of the products you make?
Some of the products that we make are Hostess powdered sugar donuts and Hostess frosted donuts. Those are actually two of the largest products, and they're in most of the grocery stores or convenience stores. They are mini donuts that come in a bag, and the powdered sugar donuts is really just a powdered sugar coat around a mini donut, and the frosted donut is chocolate compound around a donut. They're really tasty, really nice to enjoy. Some of the other products that are in the portfolio, the one that is most famous is called Twinkie, which is a sponge cake. There's also an assortment of products that have very fun names. So you have Ho-Hos, you have Ding Dongs, you have a product called Suzy Q, you have a product called Zingers. All of these products are ones that have been developed over time. In fact, Twinkies was developed in the 30s, and was developed with a banana cream. And during World War II, there was actually rationing, so that they couldn't get bananas, and they filled it with then vanilla cream. And the vanilla cream is what they actually have today. So people are very skilled in terms of what they need to do, but there's a great portfolio of sweet baked goods, hopefully that you can enjoy over time.
Mr. Riley, one of my favorite cakes are Twinkies. Can you tell us how you make them so delicious?
Why are they so delicious? Well, Twinkies is made from a traditional sponge cake, which basically uses something called a high ratio, which means that there's the weight of sugar is equal to or greater than the weight of flour. So that's a little bit of how they develop the product and make it. I think there's a couple of videos, and we actually are going to take you to a video to show you exactly how it's made.
Okay, and here's the video.
Hello and welcome to Snacks Unwrapped, where we're going inside the wrapper to uncover the truth about our favorite between meal treats. I'm Mark Summers. Snacks have been around, well, probably since someone stopped in the middle of the day and said, "Hey, I'm hungry." In fact, the oldest snack is believed to be pork rinds. They're popular now and were popular centuries ago in China. So let's start unwrapping. Recognize these? Little yellow sponge cake? Hostess Twinkies. They're more than a snack. They are practically a food group. You could trade a Twinkie for almost anything at school. And here's the tasty tidbit. They're named after a shoe called Twinkle Toes. So let's head to Twinkie Central, the Hostess Bakery in Schiller Park, Illinois, and get a tour of production. Here in Schiller Park, Illinois, they've got decades of experience making Twinkies. In fact, it's where the cream-filled snack was invented in 1930. It all started with a plant manager named Jimmy Dewar, who had lots of unused baking pans shaped like dessert shells.
One day he was driving down in St. Louis and saw a Twinkle Toes billboard, and he got the idea of calling the product Twinkies, and he would take the dessert shell, inject it with cream, and call it a Twinkie.
Dan Angst is general manager of the Hostess plant, so he knows the golden facts about Twinkies.
The process of making a Twinkie starts with making the dough.
Take one huge mixing bowl. The big ingredients like flour and water are dropped in by a machine. Others in smaller quantities are added by hand. The mixer is a guy who supervises the whole process and knows when the mix becomes a batter. The batter is pumped into individual molds, but look carefully. The curve comes from the shape of the pan, kind of like a bread pan. That's the secret. Twinkies are actually made upside down. All you see as they bake is the bottom of each cake.
After the mix is done, we pump the dough into the pans, and the pans go through a 75-foot oven for approximately 12 minutes. Obviously, you don't want to bake it too long because if it gets dark, people are used to a very nice, soft sponge cake.
After the oven, the cake cools for almost 45 minutes, while the filling is made in another part of the plant. And here's a little-known secret about the filling flavor.
Originally, the first Twinkie was filled with banana, but during World War II, there was a banana shortage. And so they had to change to the vanilla cream filling that everyone enjoys today.
Next, let's uncover the secret to filling a Twinkie. It's these metal tubes which inject the cream into each sponge cake, and all you end up with is 3 little holes.
To make it look very presentable in the package, we have the 3 entry points of the needles that fill it with cream on the bottom of the cake as opposed to the top of the cake. And that's why during the baking process you see the bottom as opposed to the top. It really becomes a Twinkie, in my opinion, after it's injected with the cream, because that's what is the favorite.
Here's a fun step. The Twinkies have been upside down until now, so it's time for a flip. Every pan hits the dump table and pop. The pans go up to get washed and refilled, and the Twinkies start their march to the wrap room.
It takes approximately an hour and 5 minutes to make a Twinkie from start to finish.
There are 500 million Twinkies made a year.
Packaging, boxing, and a final quality check, and another batch of Twinkies is ready to head out the door. Just another day in the life of a Hostess Bakery.
We can make about 55,000 Twinkies an hour. We know that Chicago is the #1 Twinkie consuming city in the United States. We're pretty proud of that, both as a consumer and as a producer.
Wow, that was interesting.
Yeah, I always wondered how they made such delicious cakes.
I have another question for you. You're a chemical engineer, right? What do they do?
2-1. So what does a chemical engineer do? It's a great question. So a chemical engineer is someone who develops and designs processes for chemical manufacturing facilities. They apply principles of chemistry, biology, microbiology in order to solve problems or create opportunities. They use a lot of engineering disciplines in terms of what you learn in physics and what you learn in chemistry, and apply that in all processes. So in the case of something like a Twinkie, they would be involved with how you mix all the raw materials together, making sure that when they react appropriately at the right time, and then transferring those ingredients into to make a batter. When that batter then goes into the oven, bakes in the oven. So a lot of different principles associated with what a chemical engineer would do.
Where did you go to school, and what is your degree in?
Another great question. So I'm from Jersey, and I went to a school at a place called New Jersey Institute of Technology, and my degree is in chemical engineering. So I have a bachelor's degree in chemical engineering.
What type of classes did you have to do at NGIT? Did you have to take chemistry?
So chemical engineering involves a lot of the principles as I described before. Some of the classes that you take are basic chemistry. You take physical chemistry, organic chemistry. Chemistry is a very important tool along with math in order to build the appropriate skills for chemical engineering. If you think about it, Kids for Chemistry, an awesome program and project. If you look at some of the unique ways and diagrams that is put together in order to have young minds really learn about the first 20 atoms, you look at things from hydrogen that goes all the way to calcium. In the area of chemical engineering, you really look at all the elements that are in between. You look at sort of their atomic number, you look at the value associated with that. So Kids for Chemistry is really amazing project, amazing game and opportunities in order for kids to have fun learning. One, I understand that you have a unique and patented diagram that helps students identify the first 20 atoms.
As a matter of fact, we have a game that helps you learn how to identify the atoms. Mr. Riley, would you like to play the game with us?
2, 1. Sure, let's play.
Before you can learn how to identify atoms, you must know what a s orbital and a p orbital is. A s orbital is a red circle, and a p orbital is an orbital that is shaped like an 8. And as you can see on this atom right now, you could see that the blue, green, and red orbitals are p orbitals, and you can see the 2 red circles are s orbitals.
Mr. Riley, we're going to be teaching you how to identify atoms. As you can see, it has 4 s orbitals, so it's in the 4th row. And if you can see that the outermost orbital is an s orbital. If you're asking why, because the p orbital is not passing it. But if the p orbital was outer than the s orbital, then the p orbital will be the outermost orbital. So, and there's 1 electron on the outermost s orbital, so it's in the 4th row. It's in the 4th row and the 1st column. That is potassium. Yeah, that's it for right. And that is how you identify an atom.
All right, Mr. Riley, I'm going to solve this atom for you. Okay, there are 3 s orbitals, so it is in the 3rd row. And the furthermost orbital is the s orbital, and there's 1 electron on that orbital. So it is in the 1st column. So your answer should be sodium. All right, let's go.
Okay, Mr. Riley. Right now, I'm going to show you what this atom is. As you see on the screen, there's 2 s orbitals, and that leads to the 2nd row. As you see on the screen on this atom, there's a p orbital. That's the outermost orbital, and that p orbital has 4 electrons. So therefore, it's going to be in the 6th column 6. So leading to that, the answer will be oxygen. Yes!
Mr. Riley, this is another item that we're going to identify. As you can see, it has 3 s orbitals, so it's obviously in the third row. And it has 4 electrons on the outermost orbital, which is a p orbital. So it must be in the third row at 6th column. If you're asking why it's in the 6th column, it's because over here it has 4 electrons and you have to count in these two, K, 19, and 20. So it's in the 6th column. So let's see if we're right or not. S16, sulfur. Let's see if we're right. Correct. And that's how you learn how to identify a p orbital.
So if you look at this atom, you're looking at it and you're trying to use the skill set based upon what was taught. So you have the s orbitals and p orbitals. Looking at this, the s orbital looks like it's 3 circles. So if you go to 3 circles, it should be the third row. And then looking at the p orbitals, it looks like there's 2 electrons out. 2 electrons would move you over to, and the third row has the row that has sodium, magnesium, aluminum. And as you go over, if you go to 2, it looks like it could be silicon. That would be in the third row and have the 2 p orbitals. So my guess would be silicon. There you go. Excellent. Got it correct. So following the Kids for Chemistry, this is how it works. Wow, this was a fantastic way to learn about the first 20 atoms. Really simple, really involved, and really focused. I sure wish I had learned about this when I was taking chemistry for the first time. It really would have helped me out in this thing. Thanks for showing me really how to play, guys.
You're welcome, Mr. Riley.
Oh, by the way, Mr. Riley, did you bring us any snacks from Hostess?
Yes, I did. Look to your right.
Wow! I got ding dongs!
And I got Hostess cupcakes.
And this is my favorite, Twinkies.
Thanks, Mr. Riley.
Mr. Riley, I hope you enjoyed yourself on our show. It was a pleasure having you.
I want to take the time to really thank Sean, to thank Joy, and to thank Nicholas. It really gives me a lot of pride and pleasure to be on the show and to work together with you. Thank you so much for having me.
Thanks, Mr. Riley, for the snacks.
You are welcome.
So until next time, see you later.